the presence of pi bond in the alkenes, which makes the alkenes to be more reactive as it is compared with the alkane. What does the Morphonic Cox Rule says that the negative part of the reagent should attach to the unsymmetrical carbon atom where it having very least hydrogen atom. Always remember, when compared to the primary carbocation and secondary carbocation carbocations are more stable. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Hydrocarbons. In that, we have discussed about the conformations of alkanes, and also we have discussed about the nomenclature of alkenes, and we have discussed about the method of preparations of alkenes, and finally we have discussed about the physical properties of alkene. Today, let us move on to the next topic of this alkenes is chemical properties. So, we are going to understand what are the different chemical properties which are exhibited by the alkene. So, firstly, I'll go with the chemical properties. We all know that when we compare the alkenes with the alkenes are highly reactive than the alkanes. The main reason is the presence of pi bond in the alkenes, which makes the alkenes to be more reactive as it is compared with the alkane. And also, in case of alkenes, electrophile can easily attach to the negative rich center to form a addition reaction. So, this is one more reasons which makes the alkene which is highly reactive when it is compared with the alkane. The first reason is the presence of pi bond and the electrophile that can easily attach to the negative part to form a addition product. Okay. So, these are the two reasons which makes the alkenes to be more reactive as it is compared with the alkane. So, the first chemical properties of the alkene is the addition of hydrogen. So, if you add the hydrogen to the alkene, what will be the product? Let's see now. So, the addition of hydrogen, alkene react with hydrogen gas in presence of nickel, palladium or platinum as a catalyst to give a alkene. Same kind of the reactions we have learned in the preparations of alkanes also. Is it right? So, the alkanes can be prepared by alkenes. So, same kind of the chemical property we are studying in case of alkene. So, here we have considered the alkene. To this, if you add the hydrogen gas in presence of nickel as a catalyst at a temperature around 250 degrees Celsius, it gives rise to the alkane. It gives rise to what? Alkane. So, this kind of reactions are also known as addition of hydrogen, or it is also known as catalytic hydrogenation. So, what is hydrogenation in the sense? The process of addition of hydrogen. So, if you add a hydrogen, it will undergo hydrogenation and forms a product called as alkane. Now, for this, I can write one more example. Here, R is my alkyl group. Now, I can write CH3, CH, double bond, CH2, and if you add the hydrogen to this, one hydrogen will attach to this carbon atom, one more hydrogen will be added to this carbon atom and break this bond, and in presence of nickel as a catalyst, it will form CH3, CH2, CH3. This is propane. This is what? Propane. And this is propene. This is propene because between the first carbon atom, there is a first and second carbon atom, there is a double bond. This is a propene. During the reaction, if you add the hydrogen, it will become propane. You can write one more example. CH3, CH2, CH double bond, CH2. If you add the hydrogen in presence of nickel as a catalyst, it will form CH3, CH2, CH2, CH3. Name of this compound is butane because it is a alkane, and name of this compound is butene. Okay, this is how our alkene, when you add the hydrogen atom, it gives rise to the alkane. Okay, next is addition of halogen. Chloro, bromo are react with alkene in presence of inert solvents like carbon tetrachloride to form dihaloalkane. Here I have considered the alkene which is allowed to react with the halogen called as bromine in presence of inert solvent known as carbon tetrachloride. It will add this halogen to the first and second carbon atom to form a dihaloalkane. It is dihaloalkane. Why it is dihalo? Because there are two halogen atoms which is attached to the first and the second carbon atom to form a alkane. Okay. So you can take one example for this. Here I have considered the ethane which is react with the dihalogen, that is bromine I have considered. In presence of carbon tetrachloride, it will add this it will add this bromine to the first and second carbon atom and break this bond to form 1,2 dibromo ethane. 1,2 dibromo ethane. Similarly, I have propene. If you add the halogen in presence of carbon tetrachloride, it will form 1,2 dibromo propane. You can write one more example for this. I'll write for the butene CH3, CH2, CH double bond, CH2. If you add the bromine, it will break this bond and forms what? CH3, CH2, CH, Br, CH2, Br, CH2Br. This is 1,2 dibromo butane. This is 1,2 dibromo butane because this is a way we are numbering the carbon atom. As it is having the double bond, it has to get the least numbering. So when you add a halogen, it gives rise to the dihaloalkanes. Okay. Next is addition of hydrogen halide. What does it mean? Hydrogen halide in the sense HX. This X is my halogen group and H is a hydrogen. Together it is known as hydrogen halide. Okay. When alkene react with hydrogen halide, they forms alkyl halide. They forms what? Alkyl halide. Here I have a alkene which is allowed to react with hydrogen halide. It gives rise to the alkyl halide. This is a R, CH and CH3, and this hydrogen will be accepted by this carbon atom and break this bond, and halogen atom will attach to this carbon atom and forms what? Alkyl halide, which forms what? Alkyl halide. So for this I have considered alkene it is. So it is ethene, which is allowed to react with HBr, which is a hydrogen halide. The name of this compound is hydrogen bromide. So alkene react with hydrogen bromide. It forms what? CH3, CH2, Br. So remember, always this CH3 will take up one more proton, whereas another CH3 will take place another bromine, or you can say that it is a halogen group. This is how when you take the alkene, when it is react with hydrogen halide, it gives rise to the alkyl halide. But in case of unsymmetrical alkene, if it is there, then the addition of this hydrogen halide will be takes place according to the Morphonic Cox Rule. What does that Morphonic Cox Rule state? That according to the Morphonic Cox Rule, the negative part of the reagent should attach to the carbon atom where it consists of very least hydrogen atom. This is known as Morphonic Cox Rule. So what does the Morphonic Cox Rule says? That the negative part of the reagent should attach to the unsymmetrical carbon atom where it having very least hydrogen atom. Here I have considered the propene. To this I have added the HBr. We know that HBr is a hydrogen halide. Is it right? Where hydrogen which carries the plus charge, whereas the bromine which carries negative charge. Is it right? This is plus charge and this is negative charge. According to the Morphonic Cox Rule, the negative part of the reagent should attach to the carbon atom which are having very least hydrogen atom. In this 3 carbon atom, the first carbon atom having a 3 hydrogen, whereas the second carbon atom are having only 1 hydrogen, whereas the third carbon atom which are having 2 hydrogen. So the middle carbon atom which are having only 1 hydrogen, which is having very least number of hydrogen. Is it right? Hence, our negative part of the reagent must attach to this carbon atom. Okay? To form a alkyl halide. So to form what? This later this H plus ions will attach to this carbon atom and forms what? CH3, CH, Br, CH3. This is named as 2-bromo-propane. It is 2-bromo-propane. This is how when you add the hydrogen halide to the alkene, especially if it is an unsymmetrical alkene, it has to be added according to the Morphonic Cox Rule. So, hope you all understood with this Morphonic Cox Rule. How do we add this hydrogen halide and to form a alkyl halide? Hope you all understood. We'll see with the mechanism now for this. The reactions which is taking place with the 3 step, that is the hydrogen bromide dissociated. The hydrogen bromide is what? Hydrogen halide, okay, which is dissociated to give H plus ions and Br minus ion. So, which is dissociated to give H plus ions and Br minus ion. The electrophile H plus attacks to the propene to form a carbocation. So, here we know that the HBr, which consists of H plus ions and Br minus ion. This electrophile, that is H plus ion, can attach to the first carbon atom as well as with the second carbon atom to form different types of carbocation. One it is named as less stable, another one is named as more stable. Okay. The 2 carbocations are also known as secondary carbocations and one is known as primary carbocation. This is primary carbocation and this is secondary carbocation. Remember, this secondary carbocation will be almost stable and it is more stable as it is compared with the primary carbocation. How does we know that? In the propene, we have CH3, CH, double bond, CH2. If you are adding the HBr, suppose if this nucleophile attacks to the first carbon atom, this carbon atom will takes up the electron from the second carbon atom and forms what? Less stable carbocation. Similarly, if this H plus ions attacks to this second carbon atom, the second carbon atom which takes up the electron from the first carbon atom and forms a more stable carbocation, and hence it gets the plus charge, where the first one will get the plus charge to show that it is a formation of carbocation. Always remember, when compared to the primary carbocation and secondary carbocation are more stable. This is a first step and the second step, where in the first step our hydrogen halide dissociated to give H plus ions and Br minus ion. In the second step, the electrophile goes and attacks to the propene to form two different carbocation. In the third step, the nucleophile, that is nothing but a Br minus ion, which attacks to the carbocation to form a 2-bromopropane. So, this is why second carbocation, that is nothing but a secondary carbocation, when it does react with a nucleophile, it gives rise to the 2-bromopropane. Our nucleophile attacks to this carbocation and forms a 2-bromopropane. This is how the mechanism will be involved during the attack of nucleophile as well as with the electrophile. So, hope you have understood with this mechanism. And remember, this mechanism, which is very important to understand how hydrogen halide will react with the alkene to form a alkenes. Okay, or you can say that it will form a alkyl halide. Next thing is Anti-Morphonic Cox Rule. The addition of hydrogen bromide to the propene in presence of peroxide as a catalyst takes place against the Morphonic Cox Rule. This is also known as peroxide effect or crash effect. So here I have considered the propene. To this I have added the HBr, which is a hydrogen halide in presence of what? Peroxide as a catalyst. Here I have considered the benzyl peroxide as my catalyst. Here the addition of this HBr takes place against to the Morphonic Cox Rule to forms what? It forms what? Alkane. It forms what? Alkane, and this is 1-bromopropane. It is 1-bromopropane. For this, let's see with the free radical mechanism. How do we write the free radical mechanism for the anti-Morphonic Cox Rule? By taking the hydrogen benzyl peroxide as a catalyst. Okay. So, in the first step, benzyl peroxide undergo homolysis and give rise to the H5 C double bond O and C6H5CO2. So, here the bond will be get broken up between the two benzyl peroxide and give rise to the C6H5 radical. C6H5 radical, which is allowed to react with HBr. Again it undergo homolysis. So we know that C6H5 is my radical, react with HBr, which accepts one of the proton and forms what? C6H6 with the Br minus ion. In the next step, This Br minus ion, this is my nucleophile, attacks to the propene and undergo homolysis and give rise to the two different products. One is less stable primary free radical, whereas more stable secondary free radical, where this bromine can attach to the second carbon atom, where the bromine can attach to the first carbon atom and forming a more stable and less stable carbocation. This more stable carbocation with further reaction with the HBr and give rise to the major product, that is nothing but a 1-bromopropane. Similarly, this less stable carbocation which is react with the HBr and give rise to the 2-bromopropane, and these two are this is a major product and this is a minor product. And remember, since the secondary free radicals are formed in the step 3 are more stable and give us the 1-bromopropane which is a major product. This is 1-bromopropane and this is 2-bromopropane which is a minor product. This is how we can easily understand how this hydrogen halide react with the alkene to give a different product. Okay. Next thing is the addition of sulfuric acid. The cold concentrated sulfuric acid adds to the alkene in accordance with the Morphonic Cox Rule to form a alkyl hydrogen sulfate, and it is followed by electrophilic addition reaction. Here I have considered the alkene which is allowed to react with concentrated H2SO4. What it will form? It will form alkyl hydrogen sulfide. So here we know that there are 2 hydrogen, 1 sulfur and 4 oxygen will be there. So it will goes and attacks to the second carbon atom and forms a alkyl hydrogen sulfate. Okay. For this I have considered the propene as an example which is allowed to react with the concentrated H2SO4. This HSO4 which attacks to the second carbon atom and forms a alkyl hydrogen sulfate. You can write one more example for this. I'll consider butene CH3 CH2 CH double bond CH2. If you add the H2SO4 for this, what will happen? This HSO4 goes and attacks to the second carbon atom and forms what? CH3, CH2, CH, HSO, SO3, H and CH2. Okay, this bond will be get broken up to form a addition product. In case of addition of water, if we take the presence of few drops of concentrated sulfuric acid, the alkene reacts with the water to form a alcohol in accordance with the Morphonic Cox Rule. We know that again Morphonic Cox Rule says that the negative part of the reagent should attach to the carbon atom which is having very least number of hydrogen atom. Here we know that the negative part of the reagent is oxygen and the positive part is H plus ions which goes and attacks to this carbon atom which are having very least hydrogen atom. Is it right? Yes, and forms what? Alcohol. So when you add the water to the alkene, it forms what? Alcohol. This is how our alkene react differently with the H2SO4, water as well as with the hydrogen halide. Next thing is oxidation. Alkene on reaction with cold, dilute and aqueous solution of potassium permanganate, which is also known as Bayes reagent, to produce is vicinal glycol. Vicinal means adjacent sides. Okay. The decolorization of K-4 solution used the test for the unsaturation. So here I have considered the ethene, which is allowed to react with the oxidizing agent known as KMnO4 in presence of water. It forms what? Vicinal glycol, which forms what? Vicinal glycol. This is how our alkene, when it does react with the oxidizing agent, it undergo oxidation and give rise to the vicinal glycol. Next thing is the acidified potassium permanganate or acidified potassium dichromate oxidizes the alkene to the ketone or with the acids depending upon the nature of alkene. For example, here I have considered the propane which undergo oxidation in presence of acidified KMnO4, that is potassium permanganate. It gives rise to the acetic acid. It gives rise to what? Acetic acid along with the release of water and carbon dioxide. Similarly, if you take the butane which undergo oxidation in presence of acidified potassium permanganate, it gives rise to the acid, that is CH3CH2COOH. How many carbon atom will be there? 3. So it is propanoic acid and it is with the release of water and carbon dioxide. Or if you change the double bond, so this is, it is 2-butene or butane which undergo oxidation in presence of acidified potassium permanganate which gives rise to the acetic acid and acetic acid mixture. Remember, just by changing the double bond between the two carbon atom, the position of the double bond, if it is altered, the nature of the product which is formed, that is also get different. This is how the alkene which react with acidified potassium permanganate and give rise to the carboxylic acids. That is, acids will be formed. Next is ozonolysis. The name itself indicates that ozonolysis means the breakage of ozone to form a ozonolysis. Okay. So the ozone adds to the alkene to form a ozonide which is hydrolyzed in presence of zinc and water to form a aldehydes and ketones. These reactions are also known as ozonolysis. Here I have considered the propane which is added with the ozone. First it will form an intermediate product where this ozone will be introduced between the first two carbon atom and forms a propene ozonide. Okay, which is upon further reduction with zinc and water, it will form what? It will form a aldehyde. It forms what? Aldehyde, and the name of this compound is ethanol and methanol. Again, I have considered the 2-methyl propene. To the second carbon atom, you can see that one which is attached. So it is a methyl group. So it is 2-methyl propene. To this, if you add the ozone, it gives rise to the ozonide, which is an intermediate product, and give rise to the aldehyde. And here, instead of forming a aldehyde, you can expect ketone here. Why is it so? Because in your carbon chain, there is a one substituent group and there is a oxygen which is obtained from the ozone and forms a carbonyl group and results in a formation of ketone as well as with the aldehyde. Okay, this is how the aldehydes and the ketones can be obtained by treating the alkene with the ozone. This process is also known as ozonolysis. Next thing is polymerization. We all know that polymerization is a process of preparing the polymers from the monomers. What are monomers then? Monomers are the simple molecules. They are joined together to form a polymer. The process of obtaining the polymers from the monomers are also known as polymerization. For this, I'll consider my alkene, which is allowed to react with oxygen as a catalyst at very high temperature and pressure. It gives rise to the polyethene. It forms what? Polyethene. So why it is forming polyethene? Because each single molecule known as monomers, they joined it together to form a chain structure. To form a chain structure or branch structure or cross-linked structure. This results in a formation of polymer. So this process of obtaining the polymer from the monomers, which is also known as polymerization. Here I have one more example. This is a propane. By treating with a suitable catalyst known as dioxygen at very high temperature and pressure, it gives rise to the polypropene. It forms what? Polypropene, which is a polymer. So this is how we can expect our alkene to form a different product when it is undergo chemical reaction. In the next class, we are going to understand more about the alkynes, nomenclature, method of preparation, physical and their chemical properties. So by this, I like to say that what are all the things which we have covered in this session, especially the chemical properties of the alkene. It is very important for the examination point of view. Have a look on it and try to make a note. We will meet you in the next session. Till that, take care. Be safe. Thank you.